Hey, welcome to Next Gen Manufacturing. We spend a lot of time talking about the massive, powerful, super intelligent machines that literally shape our world. But what if I told you the real secret to their speed and precision comes down to one small, often completely overlooked component? So today, we're going to dive into that critical link in modern machining.
Alright, so here's our game plan. We're going to start by shining a spotlight on this unsung hero, really get into why it matters so much. Then we'll break down what makes it work using something I call the performance triangle. After that, we'll dig into 4 key metrics, take a tour of the different types you'll run into, and finally see how it all plugs into the machine itself.
So let's kick things off with our unsung hero and get right to the heart of why this little piece of the puzzle is so absolutely essential.
Let me ask you this. Just think about it for a second. When you picture a high-end CNC machine doing its thing, what do you see? The massive frame? The lightning-fast spindle? The cutting tool carving away metal? Well, the most critical part might just be the one you're not even thinking about.
And this right here, this is the perfect analogy. You can have a 1,000 horsepower engine, but if you've got bad tires, none of that power actually makes it to the road. The tool holder is the high-performance tire of the machining world. It's that all-important connection that takes all the power, all the intelligence from the machine and translates it into actual work at the cutting edge. Get it wrong, and all that amazing engineering is just wasted potential.
Okay, so now we get why it's so important. But what actually makes one tool holder better than another? Well, it all comes down to a balancing act, something we can picture as the performance triangle.
These 3 things, accuracy, rigidity, and versatility, are in this constant push and pull. If you max out one, you might have to give a little on another. So the best tool holder isn't a single thing. It's the one that strikes the absolute perfect balance for the specific job you're trying to do.
First up, we've got accuracy. This is non-negotiable. It's the foundation of everything. We're talking about the tool holder's ability to grip that cutting tool so it's perfectly centered, spinning without any wobble, making sure every single cut is exactly where the program told it to be. Without this, you just can't hit the crazy tight tolerances that modern parts demand. Next, there's rigidity. I want you to imagine trying to draw a perfect straight line with a pen made of rubber. It's impossible, right? You'd get a wavy, messy line. That's what happens when a tool holder isn't rigid enough. Under the intense force of cutting, it can bend or vibrate. We call that chatter. And it completely ruins the surface finish, shortens your tool life, and can even wreck the whole part. A rigid holder is your rock-solid foundation.
And rounding out our triangle is versatility. Look, in any shop today, time is literally money. Machine downtime is the enemy. A versatile system lets you swap tools in and out super quickly, which slashes your setup times and keeps the machine making chips, which is how you make money. It's all about being flexible and efficient.
Okay, so we've got our big picture concept, the performance triangle. But how do we actually measure this stuff? How do we quantify it? Let's dig a little deeper into 4 technical keys that define a tool holder's performance.
These are the metrics that really tell the story. How much rotational force can it handle? How little does it wobble? That's the radial runout. How well does it absorb those bad vibrations? That's dampening. And of course, can it hang when the spindle is screaming at thousands and thousands of RPM?
Now, I want to pause on this one for a second, because it is a huge deal. TIR, or Total Indicated Runout. It's basically a fancy engineering term for wobble. The smaller that TIR number, the better. And why should you care? Because just a few microns of extra wobble means your cuts are less accurate, your surface finish is worse, and your expensive cutting tools wear out way faster. We're talking the difference between a perfect, profitable part and a very expensive piece of scrap metal. So remember, less runout equals more precision and more profit.
All right, we've nailed down the why and the what. Now let's get practical with the how. Here's a quick field guide to the most common types of tool holders you're going to see out there.
This chart breaks it down pretty nicely. You've got hydraulic chucks, which use fluid pressure for incredible grip and vibration dampening, perfect for high-speed finishing. Then there's shrink fit, where you literally heat the holder to expand it, creating an insanely powerful grip when it cools. That's your go-to for really aggressive milling. Milling chucks are the heavy-duty workhorses built for pure rigidity. And of course, ER Collets are the jack of all trades, super flexible and great for all kinds of light to medium-duty work.
But here's the thing to remember. The tool holder is a middleman, right? It's an interface. It has to connect to the machine spindle on one end and the cutting tool on the other. So let's look at both of those connections.
On the machine side, you're usually going to run into one of these 2 steep taper styles, CAT or BT. And honestly, they're really similar.
Both use that V-flange design, both are super rigid. The main difference really is just geography. CAT is the standard you'll see everywhere in the US, while BT is much more common across Asia and Europe.
But of course, technology never stands still. As machines get ridiculously fast and powerful, the connections have to evolve to keep up. That's where you see advanced systems like HSK coming in. It's a totally different design, engineered from the ground up for the extreme demands of high-speed machining, giving you way better balance and stability at insane RPMs.
So that's the machine end. What about the tool end? Again, you've mostly got two main players. The straight shank is, well, it's just a perfectly round, straight cylinder. Simple, effective, works great in collets. But the Weld-on shank has that little flat ground into the side. And that flat is a game changer. It gives a set screw a place to lock in, making it physically impossible for the tool to slip or pull out during really heavy cutting.
Whew, okay, that was a lot of ground to cover. So let's just take a breath and boil it all down to the absolute essentials you need to remember.
So if you walk away with anything today, let it be this. The tool holder is that crucial handshake between your machine's brain and the cutting tool's brawn. Its performance is always a balancing act between accuracy, rigidity, and versatility. When you're looking at specs, zoom in on that TIR number. That's your gold standard. From there, it's all about picking the right flavor for the job. Hydraulic, shrink fit, whatever, and making damn sure it's compatible with your spindle.
So I'll leave you with this one thought. You've heard it a million times. A process is only as strong as its weakest link. So after all this, the question you've got to ask yourself is, in your operation, is your tool holder an accelerator, launching you forward and making everything better, or is it an anchor, quietly holding you back from what's truly possible?